Hello everyone. Today we will be doing Module 1 of the Practice Digital SAT, Test 1, and we're doing questions 12 through 16. So starting with number 12, we have a graph here, and it says that the graph of y equals f of x is shown, where the function f is defined by f of x equals ax cubed plus bx squared plus cx plus d, and a, b, c, and d are constants. For how many values of x does f of x equal 0? So we know that y is equal to f of x, so it's asking when y is equal to 0. So if we look at our graph right here, we see that y equals 0 would be the x-axis here, and we just have to count how many times the graph intersects the y-axis, the x-axis. So we have 1, 2, and 3 points of intersection. So our answer should be C. Okay, question 13. Vivian bought party hats and cupcakes for $71. Each package of party hats cost $3 and each cupcake cost $1. If Vivian bought 10 packages of party hats, how many cupcakes did she buy? So this is a system of equations problem. So we want to write an equation that represents the information we're given. So we know that the total amount in dollars of party hats and cupcakes is $71. So we know party hats cost $3 each. So let's say that party hats is represented by P, and each one is $3. So altogether, the party hats will cost 3p dollars, and each cupcake cost $1. So that's just C. And altogether, that costs $71. So we also have the information that there are a total of 10 packages of party hats. So that means that we know the value of P, that P is equal to 10. So substituting that back in, we get that 3 times 10 plus C equals 71. So 3 times 10 is 30. So if we subtract 30 from both sides, we get that C is equal to 41. So that's how many cupcakes she bought. Okay, question 14. Z squared plus 10z minus 24 equals 0. What is one of the solutions to the given equation? So although there are many ways of doing this, you can either factor it or use the quadratic equation. In this case, we'll use the quadratic equation just in case you don't have any idea how to factor it. So let's say that this is in the form ax squared plus bx plus c. So the quadratic equation is that your x value, or I guess in this case, it's a z value, is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So in this case, we have a equals 1. I'll write it over here. A equals 1, b equals positive 10, and c equals negative 24. So just plugging those values in, we get that z equals negative 10 plus or minus the square root of b squared, so 10 squared is 100, minus 4 times 1 times negative 24, and then divide that by 2 times a. So we know that 4 times 24 is 96, and we have a negative times a negative, so that'll cancel out, and that gets us negative 10 plus or minus the square root of 196 over 2. So 196 is equal to 14 squared, so we can just replace that with 14. So negative 10 plus 14, that would be 4, divided by 2 is 2. And then negative 10 minus 14, that's negative 24, divided by 2, and that's negative 12. So you can write either of those solutions because it's only asking for one. Number 15. Bacteria are growing in a liquid growth medium. There were 300,000 cells per milliliter during an initial observation. The number of cells per milliliter doubles every 3 hours. How many cells per milliliter will there be 15 hours after the initial observation? So what should first stick out is that we're looking at a number that doubles every 3 hours, and we're looking at the amount of bacteria over 15 hours. So you could actually do this out manually. So if we start out at t equals 0 hours with 300,000 cells, then at t equals 3, you'll multiply it by 2, and that'll get you 600,000. At t equals 6, you'll multiply by 2 again. That gets you 1,200,000. But instead of multiplying it out every time, we notice that at t equals 9, it'll be multiplied by 2 again. T equals 12, you'll multiply it by 2 again. And then finally at t equals 15, you'll multiply it by 2 one more time. So altogether, this is 1, 2, 3, 4, 5 powers of 2. So you're multiplying your original amount, 300,000, times 2 to the 5th. So 2 to the 5th is 32. 32 times this 3 is 96, and then we can write all the following zeros. So this is equivalent to answer choice D. Number 16. Which expression is equivalent to 6x to the 8th y squared plus 12x squared y squared? So there are many ways of doing this, but first let's just factor the expression we're given, and we'll see if it matches any of our answer choices. So we want to look for the greatest common factor that we can factor out. In this case, we know that, at least looking at the coefficient, that 6 divides both of those expressions, and then we look for the highest power. So in this case, out of 8 and 2, we have that 2 is the highest that is common in both because it's the minimum. And then we have out of 2 and 2 that they're the same, so we can just factor out y squared. Then looking at what we left over, 6x to the 8th y squared, well, what's not included in this is x to the 6th. And then if we look at this, what we didn't include in our greatest common factor, we have 2, and then we included both the x squared and the y squared, so that stays the same. So we can see if any of our answer choices match this, and this is equivalent to answer choice C. Thank you so much for watching. If you enjoyed the video, make sure to like and subscribe.